Hi everyone, my name is Lauren Hawker Zafer and this is Redefining AI. Redefining AI is a podcast hosted by Squirro and the Squirro Academy. The podcast focuses on key narratives and discussions that drive digital innovation and help people understand artificial intelligence, machine learning, insight engines, and the insight era. Today, I've been joined by Thomas Diggelmann, and I'm really happy that Thomas has taken the time to join us today to share his wealth of knowledge and passion for machine learning. Now, Thomas has been working as a software engineer and specialist in machine learning for 20 years now. As a co-founder and employee of an early artificial intelligence startup, he's led various projects for Swissport, NASA, DHL, FedEx, Swiss Re, and Bauern Verlag AG. As part of his master thesis, a collaboration with Google Research Zurich, he also worked extensively on applications of natural language processing. So his solid professional experience combined with his scientific studies enabled Thomas to identify innovative approaches in the field of AI and also successfully execute complex projects. Thomas, he holds a Master of Science in Physics from the ETH Zurich and is fluent in both English and German. I will be talking to Thomas today about search, the end of search, and the kind of technical journeys that our search queries go on. As well as this, Thomas will introduce us to question answering, the computer science discipline within the field of information retrieval and natural language processing. But before we actually take the time to bring Thomas into the conversation, I want to set the scene a little with a small reflection component. Research shows that around 93% of online experiences begin with search, as it is rare for users to know what they want. They may have an idea, but they need search to guide them, to show them what they're looking for. Ask yourself, how do you search for information? Have you ever enclosed the search term within quotation marks to prompt the search engine to search for that specific word or phrase, or used Boolean commands? And what happens to a query once it enters the search bar? Where does it go, and how do we end up with the information we actually retrieve? Let's start to explore. Welcome, Thomas.
Hey, Lauren, and thank you very much for having me to this episode.
No problem. It's lovely to have you here. It's the first sort of in-podcast recording that we've had. We've obviously been in the times of the pandemic and COVID-19, so we've not had the great pleasure of being able to welcome someone personally. So it's really nice to have you in person.
Thanks.
So Thomas, you're a young and budding powerhouse that's chosen to dedicate his professional efforts to Squirro as a machine learning engineer. And we know that you studied physics as a major at the same university as Albert Einstein. So how does a physics graduate like yourself end up in machine learning?
Well, it's a good question. So I started my professional life 20 years ago, as you already explained in the introduction, in computer science, when I founded an early AI company. In the beginning, I was mainly responsible for integrating the algorithms that were developed by a third co-founder into the product. And as time went on, I got more and more interested in doing the algorithmic side of the picture, in understanding machine learning a lot deeper, which is when I went back to school and did a diploma that allowed me to go back to university. And so I chose physics at ETH because of mainly three reasons. So first, I'm curious about how many stuff works. And I think physics is a really good foundation for jumping into this scientific question and reasoning. Second, physics requires you to learn tackling complex problems, something that can help you, well, also for computer science. And thirdly, physics requires a good deal of higher mathematics, the understanding of which is also a good foundation for following the research in modern artificial intelligence and machine learning. And so I completed my studies with a master thesis in the area of natural language processing rather than physics, which also kind of took me full circle to go back into computer science. And after finishing my studies, I looked for a good opportunity to put my knowledge and experience to work. I did not want to work for one of the usual suspects, the bigger companies, because to me, it's important to drive change, to do new initiatives, and do that from the ground up. And this is why I feel Squirro and I are a good fit. And and also working with this exciting and great team is a lot of fun.
Excellent. Would you say that, I mean, obviously you mentioned sort of three main elements that you enjoyed and sort of drove you into the circle around staying in machine learning and computer science. Would you say that being able to understand complex technical problems and have a foundation in mathematics is important to get into the field of machine learning? And as you mentioned, natural language processing?
Well, I think it depends on what level really interests you. So by now there is a lot of, let's say, topics that you can also tackle if you only have a brief knowledge and know-how about mathematics and this deeper understanding. If you're after the algorithmic side of it and the architectural side of it, then it definitely helps. If you're more about putting these new models at use for a specific use case, you don't necessarily need to have this very deep understanding.
Okay, and what would you say was the division of labor there? Do you think there are more sort of deep algorithmic problems that have to be solved?
Well, it's also an interesting question. I think there is still lots of areas that are unsolved, also with respect to bias in models, bias in data sets, figuring out how certain is a model to do a specific prediction. These are all questions that you probably can only tackle if you go really deep and try to understand that. On the other hand, there's a big area that is concerned with coming up with good data sets. This also involves lots of manual labor. I think that not each and every university or research shop is interested in doing. So it depends. Yeah.
Okay, I mean, I think that that's a good strand to follow, actually. So on the show on Redefining A, we've already been graced with the opportunity to host a selection of key industry luminaries that work in the field of machine learning, many which have presented us with their own definition of what machine learning is. I think it's important. I mean, obviously, you're highlighting components that belong to that field. But if I were to ask you the same question, what is machine learning? What would you say, and what component of machine learning engineering keeps you wanting to learn?
So to me, machine learning is actually the art of finding tricks to get a computer to solve problems where the method of solving the problem does not have to be specified explicitly. Rather, the computer can learn by example, by exploiting statistics of patterns occurring within the data you're looking at. And so I am interested in everything that has to do with natural language. For example, ways how to teach a computer to understand semantic relationships of constituent words in a document, or generating natural language texts, etc. And I'm especially curious about ways how to better tackle problems such as bias in AI, something I already mentioned before. Also methods how to find out how certain is a model when it does the prediction. These kind of things are questions that keep me awake, and also where I want to read more.
Okay. I mean, it's interesting when I listen to you there. I come from like a sort of mixed background. My own background is more of an arts background, but I mean, I did study corpus linguistics. And when I hear you talk about, the machine can learn by example, and you have your own passion around, natural language processing, semantic understanding, is it really possible for a machine to semantically understand something?
Yeah, this is interesting. This is something that is debated a lot, and maybe sometimes even too less in academia. I think understanding something, well, it's a question of the definition, right? So if you take a complex language model, it can start to let's say figure out some patterns that are always appearing when looking at sentences. It can, for example, focus via an attention mechanism its view on certain verbs in a sentence. Is that already semantic understanding? Who knows? I mean, this is a question of definition in the end. What's more important is what you can do with it, right? So can you use this in order to solve a specific problem? And that's where kind of my understanding comes in, and what drives me.
Mm. It's sort of like the polarity of an engineering mindset and more maybe of a philosophical interpretation meaning behind. I think it's good that obviously you're questioning the whole understanding component. Now, we're both here at Squirro, and as you know, at Squirro, we place a huge emphasis on values and identification, and part of our collective identification comes from our mission statement. If we forefront the sort of big, audacious, hairy goal that aligns with that, namely to end search, what should we as an audience, everyone listening today, envision? What does this mean exactly, and how does it encapture your efforts as a machine learning engineer?
So ideally, a computer would understand, let's say, the state you're currently in well enough that it could infer a question that you might ask before you even ask it. So think about a good friend of yours who would already anticipate what you want to say or ask and immediately respond with an answer that already satisfies your seeking for information. To get there, a computer needs to capture much more than what you just enter into a search box. So it would need to understand your intent. That is the current goal that you have, and depending on the question, it would help to understand your emotional state and the immediate history of your observable actions, right? So, for example, so you just arrive at an airport in a new city for a business trip. You're tired and maybe a bit stressed after a long flight. You have not yet booked a hotel, so your goal is to find a hotel and get there as quickly as possible. In this scenario, you do not want your computer to offer you hints about the best attractions, nor would you like to be confronted with a list of 100 plus hotels. So you rather want one suggestion for a fitting hotel and the contact information to book a room. After this, the computer would immediately show you the quickest way to the hotel. So for our insights engine at Squirro, what does that mean? So that we would like to capture a customer's intent well enough to be able to respond quickly with information tailored to the questions that they might have. So machine learning can help to tackle this problem. It can help to detect the intent of a customer by leveraging statistical information, for example, by capturing what other similar customers would have wanted to find out. However, some customer feedback will always be required, maybe in the form of capturing their interaction with the results and the possibility to nudge the insights engine into a different direction by asking natural questions or inquiry factual information about something. Furthermore, machine learning can help to re-rank a list of documents according to the relevance an individual customer would assign based on the question they have.
Okay, and that's like a futuristic vision. I mean, you don't see that being possible immediately, but something that you're sort of working towards.
Exactly. So there are multiple building blocks that eventually could lead you to this point where you can do that.
Because it's always, and I suppose you look at it from more of a subjective perspective of what is a fitting hotel.
Yeah.
I mean, if I were in that situation, what is going into the sort of equation to define what is a fitting hotel?
Exactly. That's the problem, right? It's a problem of how can you kind of pry open your thoughts or your minds to get to this information. And the only way that's kind of possible is to look at your interaction and at your actions. You cannot just infer that by peeking into your mind.
But there is something called inferred action, is there not? Okay, and what's that?
So the idea is to you look at your observable actions, and from a statistical standpoint, what you could try is to figure out what's the intent behind these actions. But in order to do that, you usually need to have a larger statistic that you can observe, right? You need to look at what other people are doing, and then from there infer back what could be your intent.
Okay, so are we saying that we're all similar beings as well? If you're inferring back to the statistical analysis of what might be someone's intent?
Well, I think in order to do it, you to a certain extent you do that. Yes, you try to figure out similar groups of people doing similar actions, and then you try to do this. It's the same thing as if you, for example, if you have some music recommendation tool, there exactly the same thing happens. So what they usually do is they try to figure out a very well-tuned profile about what you like, and then they try to fit that or match it with other people who have the same taste. And this usually works quite well because there is some overlap, as even if we're individuals, there is quite some overlap in certain things that we tend to do together, and you can leverage this information.
But yeah, maybe from like a schemata perspective as well, and experience. I mean, we all have these overlaps in terms of schemata and experience. I mean, search, it's an interesting and extremely relatable concept, and I think that that's one of the reasons why we're talking about it today. And it's a huge part of your own engineering work at Squirro, especially as we've just mentioned, the desire to understand the intent of the user. If we look at it from a technical perspective, I'm sure there's a lot of people listening that don't really know how search works, and also what we do well at Squirro. So maybe you can give us a little bit of an insight, and can you take us on the journey behind the search bar?
Sure. Yeah. So I think what might be interesting is also a little bit of the historic part of how this started. And so at the advent of the internet, there were only a bunch of websites that could simply be organized in the form of an index that was curated by humans, right? And as the number of websites grew, this was no longer feasible. So enter search indexes. And by typing in a few keyword terms, all websites can be retrieved that contain these search terms. Fast forward a few years later, there was an explosion of websites, many of which were really low quality or are even spam websites. And so you need to come up with a way how to figure out which one of these websites are more interesting. And so Google's Larry Page came up with this famous PageRank algorithm that leverages these statistics of inbound links to websites, but it does not just count the inbound links. It also takes into account when an inbound link comes from what other page does it come, and does this other page also be referred by other popular pages.
Okay.
So this technique allows large search engines to upweight websites that are more interesting. So common to all search engines is this optimization of the user experience for speed. And this leads to an instant feedback and instant kind of gratification effect for the customer who searches for something and can quickly adapt their search given this feedback. Now, Squirro's typical customers are in the middle of these two extremes, right? So they do have many documents, more than would allow you for curating a simple index, but usually less documents than you would find on the internet. So applying this large-scale statistics is usually not possible.
Yeah.
So additionally, many of our customers are specialized in certain areas, such as engineering, where a subset of the company uses a very specific language. If somebody outside of this circle is looking for this information, they will have a hard time finding it, unless they can remember the right search terms for finding these documents. And so to start the journey behind the search bar, we let our imaginary customer enter some search terms. Now, these terms could either be simple keywords, as you would do on other search engines, or they could also enter a natural language question. Either ways, after entering the terms into the search box, they are analyzed by the so-called query processing step. Now, query processing is a pipeline of individual steps that can enhance the query with the goal of making search results more relevant.
Okay, so just a query, just for people listening who might not be familiar with the query and maybe natural language. So query is the actual search term, correct?
Exactly, yeah.
And natural language question would be something like
what color does a tomato typically have?
Okay.
Something like that. And so, as an example, query processing involves part of speech analysis of the entered terms. So with this, it is possible to boost terms that belong to a certain class of part of speech, such as proper nouns and or verbs, and so on. It can also be used to reject certain terms that typically lower the precision, such as determiners in a sentence. A second example would be automatic term expansion. This step leverages so-called word embeddings to find other terms that are semantically close to the original search terms that are part of your query. Third example is rule-based or graph-based synonym expansion. Terms such as COVID-19 could automatically be expanded to corona or COVID or maybe just a virus, etc.
And what do you mean there, Thomas, by rule-based synonym expansion? What's the rule-based component?
So the difference between this and the embedding-based expansion would be that somebody, a human being, is specifying the actual replacement rule. So they would specify that COVID-19 is also synonym for corona.
Okay.
So, after doing this, so let's assume we now have this mutated search terms that are expanded with other terms. We start to use this to search in the search index. And so the search index is a so-called inverted index. What this means is that for each document, all the words making up the document are put into a lookup table where each word points to the document that it originally came from. So as an example, so document A contains the words hello world. The lookup table then links the words hello and world to document A. Document B contains the words by world. So the lookup table now will link the word by to document B and the word world to documents A and B.
Yep.
A lookup table has the property that lookups only take a constant amount of time, so it is really fast to search for something. Imagine now that you have your expanded list of search terms. You simply take each term and check in which documents these terms appear. You do this for all the terms, and then, for example, take the union of all the documents that are found. Now we have a list of candidate documents that all contain some or all of the search terms, depending on how you combine the references. What you now want to do is to rank the documents according to relevance. There are many different algorithms that help you to identify more interesting documents given your original query. We use the tried and tested EM25 algorithm to do this, for example.
Okay. I mean, it sounds like an extremely interesting, but also quite complex process. If we're looking at that, and obviously the capabilities of search, there must have been a lot of development recently in technical capabilities. I mean, I don't know if it lies with natural language processing or computational power. what is enhancing search, not only sort of search as we know it in a private sphere, but enterprise, cognitive, what capabilities, technical capabilities are enhancing it?
So language is our preferred way of reasoning and conveying and inquiring about complex information, right? So it makes sense that teaching computers to work better with natural language will eventually lead to an improved human-machine interaction experience.
Do you think that do you think that's a generational thing though? Because a lot of maybe younger generations now might not choose language, but rich media, videos, images.
And wouldn't you say that language is still part of this?
It's very much a part, but it's maybe not the primary sort of fundament.
Well, and when I talk about language, that must not only mean like natural language, it could also be mathematics, for example.
Okay.
So depends on how you look at it. But so in my opinion, understanding natural language is a fundamental requirement to tackle goals such as creating a better information retrieval. Additionally, the more nuanced the semantic relations are, the more powerful a model needs to be. So you can no longer rely on global statistics, rather you need to understand context-specific relationships. Take sentiment detection as an example. So classic algorithms try to solve this problem by finding frequency statistics about positive and negative valence terms. However, this does not, for example, capture natural language concepts such as the logical negation of a statement. So example, this pizza is not too bad. So a naive model will just count not and bad as negative valence terms. And so the overall prediction would be negative sentiment. But we would rather judge it as neutral to maybe positive, right? And so modern NLP models offer context-aware token embeddings that allow capture such specific semantic relationships, even across longer context windows, so even across an entire paragraph or maybe even a document. And so training such large-scale models require a tremendous amount of compute and also big data sets. Luckily,
that was the question in my head. That was just the question. Like you must need like such a large corpus, I mean, to be able to train that data, to be able to identify that the negation is sort of neutral.
Yes, and so luckily, and this is probably one of the core things that came out the last few years. So what you can do is you can split this NLP task into a pre-training phase where a model learns to capture more general semantic relations, usually formulated as a language modeling task, and a fine-tuning phase that tailors a model for a specific target task. So the fine-tuning phase does still require enough training examples, but in a manageable fashion. There is even some new development going on where this kind of distinction of pre-training and fine-tuning starts to blur a bit. So one keyword is GPT-3, but essentially still the idea to leverage the compute that already went into the model for the specific problem you want to solve.
And you sound like you're quite passionate about that. I mean, if we go back to the start when you were talking about what motivated you and how you ended up in machine learning and computer science, in that respect, what are you most passionate about when it comes to these developments?
Well, it's a hard question. It's a hard question to just easily answer that. I think again, everything that has to do with natural language, it has to do with computers starting to grasp certain concepts. Your question is valid. Is this really understanding of language or not? I wouldn't say that it is, but to me, this is also not the most important part of it. So to me, it is really cool to look at these pattern matching rules form something that can be put at use for a specific problem, and it solves problems where originally you had no chance of doing it because you simply had no way of solving it.
Yeah, I mean, that sounds like a sort of extremely useful progression in that respect. If we stick to sort of natural language in the whole model arena, you know yourself that a few weeks ago we welcomed the chief evangelist from Hugging Face onto Redefining AI. And Squirro has a couple of models on Hugging Face that you lead the development of, I believe. And these are question and answering models. What do these type of models do? And where does question and answering fit into the whole landscape that we've been exploring today together?
Yes, so these models fall into the category of extractive question answering. So this is the machine learning task of answering a question by extracting a span of words from a contextual text. For example, a question could be, what color does the fruit have? And a model would answer with red, given that the context would be the strawberry is red. So as with other machine learning tasks, such a model can be used to tackle different problems. An obvious use case is to expose the model directly to the customer. If the customer is asking a natural language question that inquiries about a specific information, our platform tries to find relevant documents that are then analyzed by this extractive question answering model for a specific answer to the original question. A different use case would be to leverage the model as a zero-shot entity extraction or classification model. So you could, for example, curate a catalog of questions for a specific topic that is of interest for a group of customers. This catalog of questions could then automatically be run by the question answering model for new documents that arrive, etc., etc. So you could leverage this model to do specific tasks that where you don't have to train another classification model that typically requires lots of work that goes in.
Interesting. I mean, when I think about that, I think that obviously that the whole question and answering model, I mean, it would need to understand the structure of the language. It would have to have a semantic understanding of the context and the questions. It would also have to have an ability to locate the position of an answer phrase and much more. How difficult is it to train models that perform these tasks?
Well, that's the beauty of it. It's not really difficult.
Okay.
The thing that you need to have is a data set that contains examples of this actual task. And so in this case, it will be a data set that contains pairs of questions and context and some answer that needs to be predicted. And in this case, as you already explained, is that the prediction is a start point and an end point of this span. And that's it. So essentially you take this data set and you show it to your neural network, and you run this training process. And after this, you can evaluate it and see how well it performs. But then you're actually already there. Naturally, this is only one part of the picture. So first you need to come up with this data set, and this is hard, right? This is not easy to do. Luckily, this specific data set for Q&A, this is a publicly available data set, so you can use that. Also, the model architecture needs to be there. You need to pre-train this model first, but then you can pretty easily fine-tune it for this specific task.
So maybe the attention and neural networks, that's been sort of a lifesaver for these sort of tasks as well, as you mentioned. We're going to sort of usher the discussion to a close, and I think that obviously success is important, and you've been extremely successful with what you're motioning here at Squirro. It's always a subjective sort of concept, success, both in terms of roads traveled to success and what it means to an individual. And when we're talking about these concepts and the underpinnings with someone like yourself, how do you define success in alignment with an end user and search, full stop?
You already implied it. So measuring success is non-trivial, right? So for machine learning tasks, there are principal ways of measuring the quality of a model. However, these metrics are not easily translatable to customers' subjective experience of their interaction with the platform and success in finding information that they're after. So to me, success is when a customer does no longer have to reason about the technicalities behind their user interface and instead can interact and retrieve relevant information in an intuitive manner. So maybe this is a little bit an easy way of answering this question, but I think it boils down to this bigger idea of using machine learning not as kind of the first class citizen that you want to show to the customer, but rather keep it under the hood, and you don't really have to talk about it, but you know that it does its work and it helps the customer to find their information quicker.
Nice, yeah. No, it's been really insightful. I mean, I could talk about the topic for much longer. It's something that I find fascinating myself. But we have to close, and as we close this extremely informative session, the first one in person for a long time, I want to take this opportunity to thank you, Thomas, for sharing your experience. Have you got any final words that you want to share?
Well, thanks a lot, Lauren. It has been a pleasure. Yes, I mean, to me, this as you already said, this is an exciting topic. It's very exciting to work with Squirro on solutions that eventually will help customers to more quickly and with less effort find the information that they're after.
Yeah, everyone wants that, don't they? So thank you for listening today, everyone. If you would like to find out more about Squirro and the Insight Engine, go to the Squirro Academy on learn.squirro.com and access our educational material. Thank you.